Hi, I'm Mark Davis, National Director of Sales for MyCloud Services, and welcome to Telco 101. For new employees here at MyTel, we created this program to help you understand the history of our industry and as it developed and as it leads today. Understanding the basics helps you understand where things have gone, and also a lot of that's still relevant today, so it helps you understand the more advanced technology as well. In addition, in our industry, we use a lot of acronyms, an enormous amount of acronyms. We kind of have our own little language, and this is going to help you through that as well. The first part of Telco 101 is understanding the basics of analog services. Analog is the oldest form of technology that we use and we still use today. Basically, an analog line is also known as a POTS line. It's an acronym you'll hear more often than not. It stands for plain old telephone service, just very basic. One analog line equals one phone number and one call path. That means each analog line can only take one call at a time. Now, it's important to understand an analog signal. Analog back is basically like a wave that goes across for a 2 copper wire. Like any other wave, it eventually crashes or degrades, so we have to install what's called a repeater to reboost that signal. If you remember back in the old days, when you would make a long distance call, you had to talk very, very loud or scream at the person because the signal itself would eventually degrade, and that gets taken care of with other technology in the future. So going back to analog, how would it be used in a business environment? So basically what we would do is we would create what we call a hunt group. Remember, one call equals one phone number and one call path. So a company that would have 15 employees would want to be able to take on simultaneous calls from their customers. So a hunt group basically, and we'll use a 6-line hunt group as an example. It includes one main telephone number, that's the number that gets advertised, and that's the number that everybody would dial to get into that business. And 5 rollover. 5 rollover lines means they're just other analog lines, other analog phone numbers, and other call paths. So if a customer calls into the main number and that line is now in use, and a second caller comes in, instead of receiving a busy signal, the call would actually be transferred or forwarded to another line in a 5 rollover sequence. So basically that's used for what we call hunting or a call forward busy because that line is currently in use. Analog lines are still used today, even though the technology for itself is really outdated and dead, because analog lines do not require power. So in emergency services like alarm or elevator, it's still code required to have analog lines in those scenarios. And some companies still use them for fax or modem. With the introduction of digital services, we use a technology called a T1. T1 basically equals 24 call paths or trunks. Remember, we talked in analog services that one call path equals one phone number. Well, with T1s, it's much different because it's a much smarter technology. A group of 24 trunks or channels or call paths are used and shared by multiple phone numbers. Okay? So 24 call paths, you can have unlimited phone numbers on that. And really the concept behind it is everybody could have their own private phone number, or what we call a DID number for direct inward dial. And the concept was not everybody's going to be on the phone at the same time, so they don't have to have a 1-to-1 ratio. It's more of a 50-to-1 ratio, or I'm sorry, 50% to 50% ratio. Some more average would be more like a 75-25. The one limitation that T1s had under the standard digital services was the lack of caller ID. Once that really started hitting home in the early 90s, late 80s, it became very important to companies to have it to identify who's calling in. Since that could not be accomplished on a T1, we had to figure out a way to accomplish that and add that into digital services, and that's when we introduced what we call a PRI. PRI stands for Primary Rate ISDN, and it breaks up the 24 call paths into what we call 23B plus D. It means 23 B channels, which for voice, and 1 D channel for data. So it actually removes the amount of call paths by 1, but adds in that last channel so that the phone system can talk back and forth, and that caller ID can be passed through. Okay, so we've covered analog and we've covered digital services. Those are basically technologies of the past, some used in some capacity today. But now fast forward to the late 90s, early 2000s, and we have to get internet involved there because everybody uses the internet today, right? We're an internet society. So keep this in mind as you go through the rest of this training. Every company you talk to has 3 different services. They all have it. They have voice services, long distance services, and internet services. You really can't have one without the other in business today. We're going to go through voice and data services combined right now. So a T1, we talked about in digital, a T1 equals 24 call paths, or in a PRI scenario, 23 B plus D channels for caller ID. Well, what about data? What about internet? T1 can also be broken out into a data capacity not using any voice channels, and have up to 1.5 megabits per second. You'll hear that term a lot. T1 equals 1.544 megabits of data. So the average customer back when the internet first came out, or dedicated internet first came out, would have a T1 for voice and a T1 for data, because there are two different, completely separate systems that operate those. Well, after a while, these are very expensive. So after a while, smaller companies will want this capacity as well. So they want to buy a different type of phone system that can handle DID services, and they also had a need for dedicated IP. But having the cost associated with two different T1s in their building was very expensive and not really lucrative. So then we broke out what we call an integrated T1. Integrated T1 breaks up a single T1 into both voice and data services through a splitter. It would split off 12 trunks, half of 24 is 12, so 12 trunks for voice, and 768K for internet, or for data. So that actually brought the cost down quite a bit, and made it more affordable for your smaller company to actually have both services and share it under one T1. So after a while, things are never good enough. People had what about the companies that are high use data, and 768K internet is not enough for them, or companies that are low use data, high voice usage, and 12 trunks is not enough for them? Well, their options were to go to a T1 for voice and a T1 for data until we introduced the very first voice over IP service called Dynamic T1. Now, Dynamic T1 uses voice over internet protocol, what we call SIP today. This is the introduction of SIP. Back then it was just called an integrated T1. They used what we call dynamic allocation to determine what the need was for that customer at any given moment. So if I have 12 trunks that I have designated for voice, but they're not being used all at one time, and all of a sudden I have a very large file I want to download, well, it's going to take the bandwidth that's being used for that voice call, or that's being designated for that voice call, and convert it to data so it can be shared. Now we're going to talk about long distance. What we talked about earlier is that every customer that you're going to be talking to has three services, no matter who they are. That would be local services, long distance, and internet services. Now, in today's technology, long distance doesn't really apply as much as it used to. Services like SIP trunking or even My Cloud Business actually includes part of the long distance services, but we still understand how we break it down, because in many cases those charges still apply. So we start off with long distance on switched and dedicated services, and here's the difference between the two. When a long distance call is made from the end user customer, the call is then sent to their local carrier. It's identified as being a long distance call, and that call is sent to the long distance provider. So we call that switched because the local carrier does the actual switching, and it is more expensive than dedicated because that local carrier gets a piece of the pie. So when we're looking at a per minute cost and you look at switched services, it's much higher than dedicated because that switching part in there's a piece that goes to that local carrier. Dedicated, all it does is it basically is exactly as it sounds. It completely cuts out the local carrier by installing a circuit between the end user customer directly to the long distance carrier. And it's less per minute because that local carrier no longer has to do the switching. So that's switched and dedicated services. Now we also break long distance down into two different categories. You have your 1+, which means you're dialing 1 plus an area code, and that's for outbound services. That's when you actually initiate that phone call and you're making a long distance call. Toll-free or 800 services are inbound. That means someone's calling a toll-free number that you designated for them to call in on, and you pick up those charges. Now in My Cloud Business and SIP trunking, this is typically included, the 1+ outbound, but toll-free or inbound long distance services will always be an extra charge, so make sure you keep that in mind. Now, we're getting pretty granular here, but long distance actually breaks it down to a couple different categories. So when you're looking at a customer's phone bills, you'll see this. Intra, you'll see this term a lot as an intra-LATA or an intrastate call. What that means is the call is placed within a LATA. And a LATA is an imaginary boundary that are broken out. Arizona has 2 LATAs, where California or other states have multiple LATAs. So imaginary boundaries that the carriers identify and fall under very specific state or tariff guidelines. Intra also kind of basically means states. The state takes over the tariff, the taxes, and all the ancillary charges for that. We break down the LATA, so it's calls within that specific boundary, or within a state. So when you're calling anywhere within your state, that's considered an intrastate call, and the charges are associated based on that. Inter means calls between. So that kind of goes federal. So it kind of takes the state tariffs out of the equation, and now you're going with more of an FCC tariff, and the charges aren't always the same. You'll find that intrastate calls versus interstate calls are more expensive because the state's getting a piece of the pie, and where inter is calls between states and the federal government's involved, and that's the same tariff nationwide for regardless. Okay, to recap what we've covered so far, remember we talked about every customer has 3 services, voice, long distance, and internet services today. We're going to talk about that 4th service today that not everybody has, but if they have multiple locations, they typically have some way of communicating between offices. That's called a wide area network, or a WAN. There's multiple kinds of wide area networks. We're going to show you each and every one of them by breaking it down into a small diagram to kind of help illustrate it. So we'll start here with point-to-point T1. And that's exactly how it sounds. It's literally a circuit, or a T1 circuit, that's set up from a point A to point B, connecting locations together. There's nothing special about it. It's just a private connection between those 2 locations. So when you find a company that has multiple locations, we're kind of going back to the 90s here, point-to-point was a way of those offices to connecting so they could be more productive. The problem with point-to-point is that it was very expensive. It was literally broken down on a per quarter mile basis of what those charges that would apply. So in this diagram, I'm showing a main location with 3 remote sites, and that's what we call a hub and spoke type diagram. The concept behind this is that all locations are connected to the main corporate headquarters, but the flaw in this type of a network was that location D couldn't connect directly with location B. So you had one single point of failure in this environment. So if location A were to go down, every single other location would go down at the same time. So it really, to kind of get around that, you would have to add additional point-to-point T1s between all the other sites to make it what we call a mesh network. And that just wasn't really viable during that time from a cost perspective. So Frame Relay was the introduction of the first cloud network that we ever had. You're going to start seeing this cloud a lot. What that cloud literally means is that there's really nothing there. It's just a bunch of circuits or servers that tie out a bunch of things together. So the concept of Frame Relay was you would take your location, instead of going point-to-point direct with them, you would subscribe them to this cloud environment, this cloud network. Within that cloud, we would build what we call PVCs, or private virtual connection. Remember, the term virtual means it's really not there, that tie these locations together. So Frame Relay, basically that concept, remember what we talked about in point-to-point, is that there's no full mesh network. You have a hub and spoke. We're kind of duplicating that here. So the way this is designed now, location A can talk to all these locations through a PVC that they have within that frame cloud. But location A is still the single point of failure. Okay, so now if location D wants to make a phone call to location B, it's got to come all the way back to location A and then get back out to location B. Because they already have access to the cloud, they've already subscribed to the Frame Relay cloud, now all they have to do is create this private virtual connection within the cloud to fully mesh or to tie all these other locations together. So location D would have a private virtual connection going directly to location B, and so on and so on. Now every location is tied together. In this case, if location A were to fail or go down, these guys can still communicate. And that was very important in any type of wider network, is not having that single point of failure. Frame Relay was, in its time, was actually very cost effective, because you only had to get your circuit to the cloud. You didn't have to go every quarter mile like we did on a point-to-point. But the problem with it is that it was very slow. Okay, so if I'm buying a T1 as access to this cloud, my guarantee or committed information rate, guaranteed bandwidth, was usually only about 50% of what that circuit was capable of. So to get the same amount of bandwidth out of a Frame Relay versus a point-to-point, you'd have to have a lot more circuits built in there. It just really wasn't viable. Voice did not work very well in this environment, because what we'll talk about as we get into other segments is voice quality is a very important factor of any type of a wide area network if you're going to run voice across it. The third wide area network is a VPN, virtual private network. Meaning virtual means it's really not there. But what we're using to connect these offices together now is we're using the public internet. And public internet is just that, it's public, so it's not very secure. Now, A VPN is not something that a carrier would provide. It's not something that Mitel would provide. It's actually done by the customer themselves. So every internet circuit that's out there that you talk to, your customer will have a firewall built into it, right? So they'll have a firewall at their location. Well, that firewall has the ability to do what we call a NAT. N-A-T stands for Network Address Translation, meaning that it actually encrypts communication services and sends them to a very specific point. So your firewall does all the work here. There's nothing done by the carrier. Once you get access to the internet, you can build yourself a VPN that you would manage on your own. It's very, very costly for IT guys to actually run these things. So basically, you're creating that same type of connection within the public internet that connects your offices together. Now, this is very effective, not very cost effective because IT guys would have to manage it. It's very effective because the network's already there, the infrastructure is already there, and all you're really doing is you're encrypting from IP address to IP address. It's a very basic way of connecting offices. The reason why this didn't really last very long, it wasn't very popular, is because certain applications require certain controllable parameters, and that's really where voice would be one of those. So voice is extremely temperamental, right? You can't, if you're sending an email, you can't really see the delay. But if you're sending a voice call, you can actually hear the delay, and that's always been an issue with internet or with VPN because it's not controllable. Okay, cutting off of the VPN or the virtual private network, we kind of move into MPLS. MPLS stands for multi-protocol label switching. Remember when VPN we talked about the inability to actually prioritize traffic or prioritize applications? MPLS actually fixes that because it actually labels those packets and identifies them so that when they're going through the network, they can actually be identified through what we call class of service allocations. I want to cover class of service allocations because there's a lot of confusion around COS and QoS. So QoS versus COS. Quality of service is basically a setting on a router. All that does is it makes sure that there's enough bandwidth on that circuit at the customer's location for that call to be made. So if somebody's downloading a large file that's taking up that whole circuit, and then you pick up the phone, QoS gets enabled. It peels off enough from that circuit to make sure that call can be placed. It has nothing to do with prioritization of any kind. COS, class of service, is the exact opposite. So it's communication between the network and the customer prem to identify a specific application, giving it priority over another. Okay, so if I'm sending a data transmission from location A to location B, and I want to make a phone call, well, COS kicks in because their voice is very temperamental. Voice has to have priority to make sure it gets from point A to point B in time, and that's what COS does. It actually makes sure that these three parameters right here are fulfilled: latency, packet loss, and jitter. And this is actually where VoIP quality comes from. It's very easy to identify. So to have a stable VoIP call, and you're reading through a service level agreement that for MPLS or any other provider, latency has to be controlled, has to be within 75 milliseconds or less. Packet loss has to be controlled. We'll talk about packet loss here in a minute. Has to be 0.5% or less. And network jitter would need to be controlled within like 19 milliseconds. So let's look at latency. What is latency? Latency equals delay. So it's literally the delay from your traffic getting from point A to point B. Okay? Packet loss. When you're sending any type of information over an IP, you're breaking up into individual packets, right? Now I'm going to kind of draw a little bit of web here so we can talk through it. Now when you send a transmission through either a VPN or an MPLS environment, everything in the World Wide Web that we call it, every time you see a little cross right here, that is a server that's going to be reading that information. So when I send something to location B, I'm hitting that. Every time I hit a server, I'm taking what's called a hop. Okay? The more servers I hit, the more hops I take, the slower it gets, the higher the latency. So it's very important that we control that. So if I'm sending basic traffic here and COS gets enabled because I'm making a phone call, it's going to find a quicker route to ensure that it's within that 75 milliseconds. Packet loss, remember we're breaking things up in packets. The reality is when I'm sending something through the public internet or an MPLS connection, that information is scattering. It's going in multiple different directions and ending up at location B. Now, eventually some of those packets get lost. They just fall off the planet or something comes in before them and they're not necessary anymore. We call that packet loss. Another way of a high-level packet loss is if you have a T1 circuit coming in or any type of circuit that you're overutilizing, it's kind of like a funnel, right? So I have a funnel, and I'm pushing water through it, and it's just a little bit amount of water, it's going straight through to the bottom. But if I turn that faucet on and I go as much water as I can, and it's that pipe is too small, it's going to start spilling over. You're going to lose your packets that way. Same concept with packet loss. Now, network jitter is the delay between packets. So if I'm sending information from location A to location B, and it's breaking up in different pieces, we'll call it packet 1 and packet 2. The delay between those two packets is what we call network jitter. That needs to be within 19 milliseconds to ensure void quality. One thing that will really help you quite a bit when you're talking to your customers and they're complaining about void calls, it's actually very easy to identify what the problem is. The customer complains that they're talking over each other. That's latency because there's a delay between the call from when they start talking versus when they stop. Packet loss. The calls are very choppy. We're hearing every other word that they're talking. They have an excessive amount of packet loss. That's what's causing that quality issue. Jitter. We're hearing a big echo on the line. That comes down to jitter because the packets are coming in too much of a delay between the packets, or they're actually coming in out of order, out of sequence. It's causing that echo. So keep that in mind when you're talking to your customers about void quality. But back to MPLS. So MPLS, multi-protocol label switching. It's the same concept as VPN, but it's a completely private network. It's not public. It's not hopping on different carrier networks. It's actually staying with one provider. You're able to label your packets or label your applications to ensure that one packet has prioritization over the other within the network, which you cannot do with a VPN. I hope you enjoyed Telco 101. Just to kind of recap and go through the things that we covered and talk about a few of the key points. We talked about analog services. This is the first technology for communications that's been around since Alexander Graham Bell. How it's still used today is through, like we talked about, elevator lines or fax and modems. Really not a primary source of service anymore. Digital services came out towards the late 80s, early 90s. Still in use today. You'll actually be out there finding a lot of PRIs, and we cover the introduction of the PRI as well as the introduction to caller ID. Voice and data shared services, you'll find that a lot today too. We actually look to it more as a SIP services than we do call it dynamic anymore, but same concept, same product. Long distance service is something that you'll never get rid of. Even if it's free, it's still there. Interstate services, dedicated versus switched LD services, and toll-free. You'll find out more toll-free than you will anything else. And WAN, different WAN variables. You have your point-to-point T1, your frame relay, your VPN, and your MPLS. MPLS is very common still today. You might even be selling it out there today. But it's important to understand that the time frame between the first point-to-point T1 to MPLS is maybe 15, 20 years. That shows one thing that's consistent about our industry, and I've been here for 20 myself. The only thing that's consistent about this industry is change. So if you can't adapt to change, you got to figure out how to keep up. Thank you.